Barry, what's going on now? What is he doing right here?
We've pre-built these slinky loops that we're putting in a mat configuration, and conveniently, Matt is putting them together. So he'll be rolling it out. He's setting on the far side here is where our header trench is going to be. All our main lines will connect to each one of these individual circuits, and he's just getting ready to roll it actually out inside the pit.
How long did it take to do this whole area here?
Yes, it took us about 2 days to prep the circuits, and we did them up on dry, clean land. And then we just had them ready to roll in. So once the hole was ready, we've only been in here for around 2 hours, say. The actual tying in of the headers and the fusions takes a lot longer, but the initial layout of the mat happens very quickly.
Okay, so let's go through the process here. You're laying all this down now. What else goes in with that?
Ethanol is we use for the antifreeze at a 20% rate to just so that the water can't freeze. And the water and antifreeze is then circulated out through this field to gather the energy or gather the heat in the winter, and then is brought in. We're going to have header lines ran to the building, and that energy is brought into the building and brought to our geothermal unit. This is in the backyard. The actual foundation of the house will be in front of us. So this is a section of their backyard where they've actually buried their energy source. It's equivalent to, say, putting a natural gas well in your yard. But all their energy for their house for heating and cooling will come from this plastic pipe in the ground.
Okay, so then you're going to cover this up.
Yep. This will all be covered. It's actually going to get 6 feet of coverage, and where we are here in Richmond, as you can tell, it's really wet. We have extreme moisture, so in order to build on this land, they're going to actually increase another 6 feet on top of the 6 feet we're down. So 12 feet up will be the finished ground here. This loop will be 12 feet underground.
Wow. So now that it's 12 feet underground, what's going to happen? It's going to naturally heat itself up, or
the sun heats the first 10,000 feet of the Earth. So that Earth is basically consistent across the world, give or take 5 degrees on where you are. More closer to the equator, the higher the temperatures are. Away from the equator, the lower those temperatures are. But around our area, it's about 48 degrees is the ground temperature. So that ground temperature, this loop with the antifreeze will gather the ground temperature coming back at 48 degrees roughly. We will take 10 degrees from that 48 degrees and put 38 degrees back into the field. That will then come back at 40 degrees. So this is just the heat exchanger at which we're able to extract the energy for the building.
How hot can I get a house with this?
You can get that a house as hot as you'd like it to be, uncomfortably hot. There's no limitations.
Now this also works, but for cooling also. Like in the summer when it's hot, this will help in the cooling process.
Certainly, it works the exact opposite. We take the heat from the building and then we push that heat out into these loops. And since the ground is 48 degrees, and compared to a conventional heat pump system or an air conditioning system, they have to displace to the air temperature at which the summer is. So say it's 90 degrees. They're trying to dump the heat into 90 degrees. For our air conditioning, we're going to take that same house heat and we're going to drop it into 48 degrees. So it's a lot easier to transfer that heat into a lower temperature than it is into a higher temperature. So that's where we gain efficiencies even against a conventional air source heat pump system, is we have a better displacement temperature than what they do. Air temperature is varying and it changes all the time, whereas the ground temperature stays pretty well consistent.
How big a crew you're working with, and how long a project is this to get it to completion? For this house is 12,000 square feet.
This 12,000 square foot house, depending upon how much custom is involved in finish, is probably going to range somewhere between 8 months to as much as 2 years. For us, we're able to manipulate or time ourselves correctly so we can have many projects undergo. This loop will go in now, but we might not be doing the next section of work for another couple of months. So if timed correctly, you can run a lot of big projects, but the timing is crucial.
Let me ask you a question. Now, you've been doing this for a long time. Geotech is very well known, very well respected company. How many jobs do you have going right now?
We have 11 projects underway right now. Yeah, and we do from large buildings down to, we even have a couple of small buildings. We Geothermal has applications everywhere. We specialize in custom homes, so a lot of the times we find customers that want a little better quality, a little better finish, so they're willing to spend the extra money to guarantee that their house that they plan on living in for a long period of time is going to give them the longevity and efficiencies that they're looking for.
What are some of the things that maybe be a problem area with thermal type of thing?
Bad installs. Bad installs is our worst enemy. Now, it's not necessarily always the fault of the person that's putting it in. There's some issues with actual legislation or codes. In BC, it's 70% install geothermal minimum. But if you look at the 70% install and you do a calculation based on a computer bin analysis, you'll find that 10% electrical auxiliary a year works into 50% of a yearly budget. So if you designed a system at 70-30, 70% geo, there's a good chance it's not even going to be operational when it's cold. And you can't get savings if it's not running.
And the savings are quite significant, right?
Oh, certainly. We are well over 50% savings. I haven't done the calculations in quite a few years because it never comes up anymore. But you're at least 50% better in heating and air conditioning.
Any new inventions that's come along that's made this a better system, or has it been pretty much the same over the last number of years?
The refrigeration process is pretty well the same, and as it has been for the last 50 years. But we have had advancements in compressors, higher efficiencies, higher COPs, coefficient of performance. So we're getting a lot more bang for our buck than we ever did out of compressors. We've changed to new refrigerants that are allowing us to get a little higher temperatures than we used to get. Every day in geothermal, they're advancing. But in the same instance, we still have manufacturers that their equipment is exactly the same today as what they sold me 15 years ago. They've kept them the same, parts are the same. You can always get the system fixed or products compatible with the new products compatible with old equipment, whereas in a lot of other industries that's not necessarily the case. Unfortunately, you buy something today that may already be obsolete by tomorrow.
Of course, that's with anything today, right? Every computer and everything we buy. Well, this is fascinating. Well, we'll keep following through the process and showing people about that. Any questions that people might have about geothermal, of course, they can come on the website. We'll put the questions together, come back and talk GeoBarry here. Then, watch the processes as we go along. And I think we're going to come up and also have you show us how a fusion is done. Is that right?
Correct. We'll go through a fusion, and I'll show you exactly how we put the pipes together, and then I'll show you how it's one consistent piece once everything's done. So you never have to worry about the actual fusions being done in your yard.
So we'll watch this being laid out, and then we'll go get fused.